So we have a user sends a question using the Docker environment there. The question response goes to the Amazon AgentCore runtime, and then we have several tasks, and this customer support agents talk to Amazon Bedrock LLM. We have agent core memory, then we have agent code identity, but we have Amazon Cognitor, which is doing the authentication of the user. When the user is authenticated, they can be able to access the agent core identity. Then agent core identity gives us access to agent core runtime. With agent core runtime, we can be able to do a task, maybe a task one where agent core gateway can talk to Lambda. Okay. Also, we can be able to do observability. That is, check the metrics. Okay. So agent core gateway can talk to Lambda, and then Lambda can talk to agent core identity, but the reverse can also happen. Okay. So we want to see what we can build. So we have the prerequisite and overview. This workshop assume you have good understanding of generative AI area and are familiar with solutions like AWS, Amazon Bedrock, AWS Lambda, and hands-on experience with Python is recommended. I'm not badly off. So you have two options to run this workshop. At an AWS event, we provide everything ready to go on a browser-based IDE and a terminal, so you can start right away. Follow instruction to set up your own machine. The workshop contain number of example on how agent core CLI works. So this workshop is focused on CLI, command line experience offered by agent core CLI. So we recommend to make proper Python setup as shown in the next step, and work with preferred IDE. We suggest Kiro, but any IDE will work. So click next to get started. So I have already done all this and got my code. So confirm if you are in the correct region. Okay. I think region we are using here is one. Yes, is one. So let me open this in a new link. I want to see if we can open the IDE. Discord editor URL. So I close this. Okay, we have the URL, so we can proceed and talk. So okay, I think our ID is okay. So now we check the node version. So write node onto version 20 point something. So let's run this command. We are told open terminal and run, confirm your identity and region. So we paste. We check AgentCore version. We install. What is we install? What we install something there. npm install we are installing global AWS CDK, and then we check the version. That one is done. Okay. Then we check for we write cloud the AI. We press enter. I think so. So here we are told. Oh, so we write cloud, we can see it here. Let me maximize the screen. So we have cloud. Wow, this is so good. Wow. This is so good. This is so nice. So we have reached this step, and you are told you can ask about in a file, explain what does main Python does, and paste code snippet directly in the session, or ask it to help you understand the AWS concept. If you are self-paced running, have crowd code or similar tool installed or a similar tool installed locally, the same approach works. Okay. We are told crowd code is a helpful companion but entirely optional. Every step in this workshop is self-contained. You can complete our lab without it. So I think I haven't used this crowd. I see people like talking about crowd code, but I never talked about it. Okay, man, this is so technologically advanced, man. Okay, so you will need three things before lab 1. You are locally tool installed, AWS account configured, and a small cloud formation stack that provisions shared resources, Cognito, Lambda, SSM parameter, and what used throughout the workshop. So since I'm learning through this, I don't we can't worry about cost. So we have Node, we have USB, we have AWS CLI, and we can learn it. Let's run this code. So I think we create another terminal. So I think, is there step 1 or step 2 the same? Let me just do everything. So we are in part 2. I think I had my skin in for now. So we have been able to set up the logins. So one moment. We have been able to set up the CLI. The CLI commands. here you can be able to see this is where I got the CLI credentials. Okay, so let's verify if everything is working fine. Yeah, everything is good. Okay. So we are in part 3, deploy the prerequisite stack, this cloud information stack, create a shared resources that little labs depend on. So we have coordinator, we want a Lambda function, and then we want the SSM parameter, and we will use Amazon coordinator for user pool and app client for authentication. So we will use a Lambda function, a remote tool. We will expose via gateway in the lab 3. SSM is for storing ALN and configuring the values used throughout the lab. So use the button to match part. I thought what? Use the button to match a region you choose in part 2. Okay. Oh shit. How will I log in? I can't be able to log in. So let me just use this CLI to create that cloud formation stuff. Oh shit. Let's use the link here. So this one is working. Okay, so you can see it's already pre-filled. Okay, so we are supposed to acknowledge here. Then we wait here. We are told to wait for 2 minutes, then we verify. Let's check in the resources. Nothing has been created. So let's try again. Or did we miss something? So They are saying the resources already exist. Okay. So we want to use CloudWatch for observability. Lab 4 uses CloudWatch traces to show you that your agent is doing is what your agent is doing in the production. Transaction search is the feature that indexes these traces so you can query them. It will require one time opting per account. So we open CloudWatch console, then we in the left navigation under the application signal choose transaction search under application signal. So we open CloudWatch application signal, then we check the transaction searches. Enable transaction searches. Okay. So this is already enabled. Transaction searches. What I think it's already enabled. I can't see anywhere to toggle on that button. So let's try to run this. So we are in lab 1. That was prerequisite. In this lab, you will build a customer support agent that answers a question about product, look up return policy such as for web for troubleshooting help. You can scaffold the project with the agent core AI, add your own tool, test it locally, deploy it cloud. By the end of the lab, your agent will be running agent core runtime accessible via agent core invoke and ready for capability. You will layer on the later lab. So step 1, we are creating a project, then we are opening a cloud editor so that we can so we open terminal, already done that. Then if you are using agent core CLI, because CLI I think is the simplest one. So we clear our terminal. So we are using agent core, we are creating a agent, the name, the framework, the provider, and no memory. So I think we copied it wrong. So this is what we are supposed to see, and we open the agent core JSON. So this, okay, it's already done. You can see it here. They had already done that. Okay. So it does not have memory, it does not have agent knowledge bases. Like, man, just saying for 1 year without learning about AWS, it has changed so much. So you can even be able to attach payments. Okay. So we are told to go into this folder. Let me organize. I think my screen hanged. So step 2, explore the project structure. This is what we have, the same, you can see it here. The same structure is the same structure. Okay. The file we will work on most, we will work on main.mm, customer support main.python. This file. Then we will work on load.python. Okay, I can't see it. And okay, in the model folder, this one. Then AgentCore JSON, this one. Okay. So step 3, we customize the agent with the customer support tools. So we are told the generated project comes with the same add number tool and an XAAI-MCP client that is replace the sample tool with customer support tool. So we open this main.py. So we are told we replace this entire thing with this code. So copy this code and paste. So the other one had like a what do you call it? Add number. But this now has the data for our fictitious e-commerce site. Okay. So we save this. So we are told we run a certain command. So we are told to ensure the copy paste was successful, run this check on a terminal to confirm the file pulses and has the right function and does not have this old sample code. So this is what we should see. Okay, pulse, and we can see it here, and 0 and 107 AP. So we go the pin model. The model load py selects model version for you, pin it exactly. So in the lab, so okay, like this has selected the model for us. Okay. So but here they are saying we use 4.6 cloud sonnet. So we save the file and we run the command to verify on our terminal. So we have the command python 3 and we can see 1 So we are told to wipe in the model globally. Cloud Sonnet 4 to 6 is a cross-region inference profile. The global prefix lets Bedrock route your request in whichever region has capacity and improve throughout the series. Note Cloud Sonnet 4.6 has no date suffix. Okay. When the other one had. The other one had suffix. So shift Z. Lab 2 to through 4 import the same load model function, so pinning it once here, apply everywhere. So at this point your architecture looks like this. An agent has two custom tools, MCP connected through web search, or running on your machine. Okay. So we have a local environment, we have a customer support agent, we have AgentCore, then we have the app and agent MD. So step 4, back in the terminal, launch the agent. Able to release. Let's ask this crowd calling, what does my Python do? So let's maximize the screen so we can read. So this crowd code is able to go and see what our main.py do. Okay. So our main.python does, it has two local tools are defined. Get the local policy, lookups the return window condition, refund. Okay, sawa. So I think the agent now is connected, and we can ask it questions. Like we are told to ask it what is the return policy. Mhm. The return policy for electronics in 30 days from purchase. I will return it with original packaging, and item must be unused or defective, and further refund. Okay, it's working. Tell me about wireless headphone. Okay, you are telling me even about the price. That is nice.